Welcome to the deep dive. Today, we're cracking open the world of Linux. It's a real cornerstone in cybersecurity, you know?
Definitely. We've got some great material here, basically excerpts from an intro module covering Linux and SQL.
Right. So we'll touch on its architecture, the different flavors it comes in, distributions, they call them.
And how you actually talk to it using the shell, plus a bit on installing software.
Yeah, the goal here is pretty straightforward. Give you a solid understanding of why Linux is so vital, especially in security, but without, drowning you in jargon.
Exactly. We want you to grasp the fundamentals, the stuff security pros really rely on. Think of it like understanding how a basic lock works. You don't need to be a locksmith, right?
Good analogy. And why should you care? Well, maybe you're just trying to get a handle on the tech landscape.
Or thinking about a career change. Or maybe you're just curious.
Whatever the reason, getting the basics of Linux gives you a huge leg up. It's not just knowing what it is.
It's understanding how it works and why it's the system of choice in so many critical areas, security especially.
We're aiming for those aha moments today, those little insights that make it all click.
Okay, so let's dive right in. Why Linux for security work? Our sources point to some key reasons.
First big one, it's open source. What does that really mean, though?
Well, think of it like a recipe anyone can look at. The code is out there, freely available.
So lots of people are looking at it from a security perspective. That sounds good.
It's huge. Constant scrutiny by a global community means vulnerabilities, weaknesses are more likely to get spotted and fixed fast.
Like having thousands of proofreaders for the same book.
Exactly. And because it's open, security folks can tweak it, customize it.
They can tailor it for specific security tasks, remove stuff they don't need.
Precisely. Makes the system harder, more resilient, like a custom-built vault versus an off-the-shelf one.
Right. And then there are versions specifically for security. The source mentions Kali Linux 6.
Yeah, and it notes the trademark. Kali comes packed with tools for things like penetration testing and digital forensics.
Okay, penetration testing. Oh, that's like ethical hacking, right? Trying to find weak spots.
Exactly. And digital forensics is the detective work after something bad happens, figuring out what went down.
Having a Linux version built for that must save a ton of setup time.
It really does. Plus, just the general flexibility of Linux, especially the command line, gives security pros really fine-grained control, which they often need.
Okay, so the why makes sense. Let's peel back the layers a bit. How is Linux actually structured? The sources say it's layered.
It is, and it starts with you, the user. You're the one kicking things off, telling the computer what to do.
And my requests, like opening a web browser, they go through applications, the software I'm using.
Correct. And interestingly, how you get those applications on Linux often involves package managers. We'll circle back to those.
Got it. Next up, the shell. What's that about?
Think of the shell as your translator, specifically a text-based translator, a command line interpreter.
So I type commands like actual words, and the shell figures out what I mean.
Yep. It takes your text commands and passes them on to the core of the system, the kernel.
And there are different shells, like bash.
Several, yeah. Bash, Karash, Kote, TCS, but bash is super common, especially in security circles. They all do the same basic job, though. Let you talk to the kernel with text.
Okay. Then there's something called the File System Hierarchy Standard, FHS.
Right. Picture a librarian for the operating system. FHS sets the standard for how files and directories, folders, basically are organized.
So the system always knows where to find things, like user files go here, system files go there.
Exactly that. It provides structure and predictability. Really important.
And that brings us to the kernel, the brain you called it earlier.
Yeah, the absolute core. It manages everything. Running programs, memory, talking to the hardware, routing commands from applications. It is Linux, in a way. The Linux kernel is unique.
The secret sauce. I like that. And finally, the physical stuff. The hardware.
Which breaks down into two types. You've got peripheral devices, your monitor, keyboard, mouse, stuff you can plug in and unplug.
Okay, easy enough.
And then the internal hardware. The essential bits inside the box.
Like the CPU.
The CPU, yeah, the central processing unit. Does the actual computing, executes instructions.
And RAM, random access memory.
That's the short-term memory. Holds data for active tasks. But its volatile data is gone when you power off.
Unlike the hard drive, that's the long-term storage, right? For programs, files, everything.
Correct. Keeps your data safe even when the machine's off.
So, putting it all together. User applications, via package managers maybe. Shell kernel make file system hardware. It's quite a chain.
It is. Like a well-run company, each layer has its role. Understanding this structure is pretty crucial for security pros. Helps you see where things might go wrong.
Makes sense. Now, you mentioned Linux isn't just one thing. There are different versions.
Right. Different Linux distributions or distros. Think of them as different editions, built on the same Linux kernel, but packaged differently.
With different software included, maybe different settings.
Exactly. Tailored for different purposes. We already mentioned Kali Linux, Debian-based, packed with security tools.
But not the only security option, the source said.
Correct. There's also Ubuntu, very popular, also derived from Debian, known for being user-friendly.
Does Ubuntu have the usual windows and icons, a graphical interface?
It does, yes. A GUI, graphical user interface, alongside the CLI, the command line interface, makes it approachable. Used a lot in security and cloud computing. Big community support, too.
What else?
Parrot is another security-focused one. Also Debian-based, like Kali. Lots of tools, but also aims for a user-friendly GUI.
So, quite a few options based on Debian. Any others?
Sure. Moving away from Debian, there's Red Hat Enterprise Linux, or RHEL.
Oh, Red Hat. I've heard of them. Enterprise means it's for businesses.
Primarily, yes. It's subscription-based, so not free like many others, but you get dedicated support and stability guarantees, critical for big companies.
And what about Alma Linux?
Alma Linux is interesting. It's community-driven. It popped up as a replacement for CentOS, which was another Red Hat-related distro that changed its direction.
So Alma Linux aims to be like the old CentOS compatible.
Yes, specifically CentOS 8 compatible. It filled a gap for people who needed that stable, free, enterprise-like option.
Wow, quite the variety. From hardcore security tools to user-friendly desktops to enterprise workhorses.
It really shows the flexibility of Linux. And managing software across all these different distros, that brings us to package managers.
Right, you mentioned those. Software comes in packages, and these packages might need other packages to work. Dependencies.
Exactly. Imagine trying to install a program, and it tells you it needs 5 other little helper programs first. Then maybe those need other things. It gets complicated fast.
Sounds like a headache.
It would be. But package managers automate all that. They install, update, remove software, and they figure out and handle all those dependencies for you.
Like a super efficient assistant.
Pretty much. And as the source points out, distros from the same family often use similar systems, Debian-based ones like Ubuntu and Kali.
They use .deb packages.
Right. And they often use a tool called APT, the Advanced Package Tool, to manage them from the command line.
And Red Hat-based systems.
They typically use .rpm packages and tools like YUM, or its newer version, DNF.
So you type something like sudo apt install on Ubuntu, maybe?
Exactly, like sudo apt install Firefox, or whatever the application name is. That sudo command is important too.
Gives you admin rights, right, for system changes like installing software.
Precisely. It stands for super user do.
Yeah.
And keeping those packages updated using the package manager is absolutely critical for security.
Because updates often contain security patches, fixing newly found holes.
Yes, vital fixes. Running sudo apt update and then sudo apt upgrade on a Debian system, for example, is a routine task to keep things secure.
Okay, practical stuff. Now, the source material talks about hands-on practice using Quick Labs. Even with maybe some access changes, the concepts are key.
Absolutely. Understanding the process is valuable. You launch a virtual lab, get a terminal, often in your browser.
Right, buttons like Start Lab, End Lab, maybe Open Linux Console for a bigger view.
And that Check My Progress button sounds useful for learning. Instant feedback.
Yeah. And basic terminal interaction. Copy-paste is mentioned. CTRL plus C, CTRL plus V. Though CTRL plus C can also stop a command inside the terminal.
It can, yes. It sends an interrupt signal. So sometimes you use the mouse or specific copy buttons in the lab interface itself.
Good to know. And navigation, getting around the command line.
Key shortcuts.
Oh.
Clear or CTRL plus L wipes the screen clean. Very handy.
Keeps things tidy.
Then CTRL plus A jumps your cursor to the start of the line you're typing. CTRL plus E jumps to the end. Saves a lot of arrow key mashing.
Oh, that's useful. And arrow keys for history.
Up and down arrows cycle through previous commands you've typed. Huge time saver. And the tab key.
For auto-completion, like you type part of a command or file name and hit tab.
And it tries to finish it for you or show you the options. Essential. Cuts down on typos, too.
The source even gives tiny examples, like the echo command.
Simple, but useful. Echo, let's print hello back to you. Echo some longer text, prints the text inside the quotes.
So quotes group words together for echo, and expr for math.
Basic math, yeah. X for 10, 10 plus 5 would output 15. Important note, spaces around the numbers and the operator plus XX for multiply for divide are needed.
And it only does whole numbers. integer math.
Correct. No decimals with Xpria.
Eh.
And then clear again, just to wipe the slate clean.
It also shows installing and uninstalling, using apt as the example. Sudo apt install Suricata. Suricata is a security tool, right?
It is, yeah, an intrusion detection system. Or sudo apt install TCP dump, another network analysis.
Or apt remove Suricata would uninstall it.
Exactly. And you can check if it worked by just trying to run the command, like typing Suricata. If it's installed, you usually get version info or usage instructions.
And if not,
you'll likely get an error, like command not found or no such file or directory. Clear sign it's not there or not in your system's path.
You could also list install packages, right? At apt list installed.
Yep, and then search through that list. A bit more thorough sometimes.
Okay, makes sense. The source wraps up with some common troubleshooting tips too. Browser issues.
Yeah, use an up-to-date browser. Chrome, Firefox, Edge are usually recommended. Clearing cache or using incognito mode can sometimes help with weird website behavior.
Standard web troubleshooting, basically. And internet connection.
Crucial for online labs like Quick Labs. If things freeze or you can't type, it might be your connection. Check on another device. Maybe restart your router.
And for Quick Labs specifically, just restarting the lab can fix glitches.
Often, yes. If you run into quota limits, though, you'd need to contact their support.
This has been really comprehensive. We went from the why of Linux and security, through its layers, the different distros.
Package managers, interacting with the shell, even basic commands and troubleshooting.
And the source even has a mini glossary defining terms like bash, kernel, shell, package manager, penetration test, digital forensics.
GO, CLI, open source. All the key buzzwords, really. Helps solidify the concepts.
So for you listening, what are the key takeaways? Hopefully, Linux feels a bit less mysterious now.
You should have a foundational grasp of what it is, why it's so big in security, its architecture.
How you talk to it via the shell, how software gets managed with package managers. You've seen the variety, the different distributions.
Maybe you had a few of those aha moments we were aiming for. It's powerful stuff, but it's built on logical layers.
Absolutely. And like we said, this is just scratching the surface. The Linux world is huge.
So much more to explore. Specific commands, scripting to automate tasks, server stuff, how it plugs into cloud tech.
So think about what piqued your interest today. Was it the different distros, maybe Kali versus Ubuntu?
Or perhaps the idea of using the command line, trying out some basic shell commands. That could be your next step.
And here's a final thought to chew on. Our world's getting more digital every day, right? Security is paramount.
So is understanding the basics of systems like Linux becoming less of a niche tech skill and more?
Right.
Well, more like essential digital literacy.
Yeah. Could knowing a bit about these underlying systems be valuable for almost anyone in the future, regardless of their job? Something to think about.